Hello, we are now looking at section 4.3c, and here we are going to look at how to graph the logarithmic functions and then how to graph the transformed logarithmic functions. So first, simple basic function, y is equal to log of x to the base 2. So y is equal, let me show you, f of x is equal to log of x to the base 2. Now you can do it in two ways. You can think of it as the inverse function because it is the inverse function. So if you can think in terms of the exponential function. So this function is inverse of g of x equals to 2 to the x. So these two are inverse of each other. So if you remember the table that we used for the exponential function, so it was xy. So we had -1, 0, and 1. And at -1, we were getting the value 1/2. At 0, we get value 1. At 1, we get value 2. So now we can use this table to get our points for the logarithmic function log of x to the base 2. So we can use this to get this table. But now what will happen, the values will get interchanged. The y values will become the x values here. So 1/2, 1 and 2 go up here, and the -1, 0, and 1. These come for the y values. Now if you want, you can get more values if you want, and you can go back to the exponential function, write its few other values, like for example -2 and 2. So at -2 you would have gotten here 1/4 and over here 4. So which means if I include the 1/4 and 4 here, then this will give me -2, and this gives me 2. So now we can try to graph it. Yeah, I think I would. Okay, that's fine. Okay. Okay, so now when you graph this function, let's plot the points. So we have at 1/2, which means over here the function is at -1. At 1, the function has the value 0. At 2, the value is 1. At 4, the value is 2. And at 1/4, which is over here back close to 0, the value is -2. And now if you so this is how you can draw the function. This is the log base 2 of x. Now note here that we could have, instead of now going from the exponential function to the get the values for the logarithmic function or make the table for the logarithmic function, we don't have to do that. So if you look at the x values here, what are these? These are just we get these by changing the powers on 2. So in this case, this is 2 to the negative 1. So 2 to the negative 1 means power is negative 1. So that is what we are getting. The powers are coming over here, and here we are getting what we get by applying that power. So 2 to the negative 1 is 1/2. That's what I have here. 2 to the 0 is 1. That is what we have here. But the power is for the y value. So next time we will do the with the power next. So let's write the domain here. So you can see the domain is 0 to infinity, and the range is minus infinity to infinity. And there is now x-intercept. You can say just x is equal to 0, or you can say 1, 0. And then we have vertical asymptote. In this case, v is the y-axis. So x is equal to 0 is the asymptote for this function. The next example is asking us to graph log of x base 1/2. Log of x base 1/2. So now, this time, so remember this one, these graphs, we are graphing them by taking points because these are not the transformation, these are the basic functions. The basic functions you cannot use transformation of what, that doesn't make sense. So powers of 2, well, when we apply negative 2 power to 2, so to 1/2, sorry, now the powers of 1/2, whatever we have here as the base. So powers of 1/2, if you apply negative 2, it will become 4, and negative 2 will come here. Okay? So if you apply the power negative 1, then you get 2 here, and the power was negative 1, so it comes here. And then we have the power will be 0, so it gives us 1, so the 0 comes here. When I apply the power 1, I get 1/2, and the 1 comes here. Power 2, I get 1/4, and the 2 comes here. And now we can graph that. Okay. So notice here I'm not leaving much space on the left side of the y-axis. The reason, you can see that our graph stays on the right of the y-axis. Okay, so now plotting the points. At 4, the value is negative 2. At 2, the value is negative 1. At 1, the value is 0. At 1/2, the value is 1. And 1/4, the value is 2. So what happened here? Can you see? If you compare this graph with the first graph, you can see that this one is a reflection of the previous graph over the x-axis. So what is the difference between them? This is the log of x to the base 2, and this one is log of x to the base 1/2. So these, and in other words, this one is log of x to the base 2 to the -1. Okay. So the next graph they are asking is to, we want to write the domain. So the domain will be again 0 to infinity, and the range will be -infinity to infinity, and the x-intercept is still 1, 0, and the VA is x is equal to 0. So in all these, most of these graphs that I'm drawing, you will see that the domain range, asymptote, and the intercept is same. But in some cases, it might be different. So the next one we want to draw is a log base 2 of -x. Now you might say, well, why -x? We can't have negative values. Yes, we cannot take log of negative values, but this suggests, so number 3, okay. So, but one thing you might consider, what do you think it will be? If you recall from the transformation, this is actually a flip over the y-axis, and that's what we expect to get. And if it's negative x, it means we have to take only the negative values for x. We cannot take any positive value, because positive value will make it negative, and we cannot take the log of negative numbers. So when I make my table, so I can take the same values that we were taking before, like the ones I have here in the second example, but they will all be negative values. So at -4, -4, we will have the value 2, and at -2, we will have the value 1. At -1, we will have the value 0. At -1/2, the value will be -1, and at -1/4, the value will be -2. And now we graph it. So now this time we need more space on the left side. So 1, 2, 3, 4. Okay, so -2, 2. Okay. So plot the points. So at -4, we are at 2. At -2, we have to be at -1. At -1, we are 0. At -1/2, we are at, and then we, so this is the graph. And notice here, this is the flip over the y-axis, which makes sense. The next graph is y is equal to, or the f of x is equal to log base 2 of absolute value of x. So what do you think will happen here? Can anyone think? If you recall, absolute x is equal to 1 if x is greater than or equal to 1, and it is negative 1 if x is less than 0. So there should be this definition suggests there should be two pieces in the graph of this function. So you can see we will have the log of x base 2 if x is greater than 0, because we cannot have equal to sign, and then we will have log of negative x base 2 if x is less than 0. That is what the piece, which means we have the two pieces, this first one and the third one. And here I have it for you drawn already. So this is the graph of log of absolute value of x base 2. So you have both the pieces. So this is the piece log of negative x base 2, and this is the piece log of x base 2. Okay, the last in this on this page was the absolute value of log of x base 2. So there is a difference between this one and this one. So what happens here? The absolute value, what it does, so we cannot have now a negative output. So any output will be positive. So we remember when we are making the table for simple log of x base 2, like in this first example, we have, for example, this, looking at this table. So we have some negative values. What will happen? Those values will become positive. So instead of negative 1 and negative 2, we will get positive 1 and positive 2 here. So what does that mean? It means these pieces, this piece which is below the x-axis will flip above the x-axis. So this will go like, this piece will become something like that. This piece gets reflected above. Let me show you the graph. Okay. Here is the graph. So this is the function where the absolute of the whole graph. So this is what the basically if you make the absolute sign, put it outside the function, or you can say put the function inside the absolute bars, it changes the graph like this. Anything which is below the x-axis will flip above the x-axis. For example, the graph of x square minus 1. So x square minus 1 looks like something like this, right? Now if you put absolute values around it, it will become, so it comes from here, it goes down and then comes up. So this piece that was supposed to go down, it goes up. So this is how the graph looks. Okay, so now the next example is asking you to sketch the graph of log of x and then ln of x. So I will let you guys try this. Remember, you can use the same technique that we have done before. So here you can take make your table with powers of 10. So you can have 10 to the -1, 10 to the 0, and 10 to the 1. Now if you do 10 to the 2, you know your answer will be like you will have to go up to 100 x for the x value. Now y value is not bad, it's just 2, but would you want to draw 100 tick marks and go there? No, we don't have space, we don't have time, we don't have energy, we don't recommend it, so we are not going there, because this is going to be 1/10, which is already very small. So how much smaller can you go? Then if you take -2 power, it will give you 1/100. Again, it will be a very, very small value, unless you take a quite big, huge step, like if your 1/0 is here and the 1 is here, maybe then you can say this is like 100th or this is 100th, but then what about the rest of the values? So we are not going to do any such things. So with just these 3 values, you should be able to show the graph of the log x base 10, because remember that's what it means. This log x means base is 10, and then this means base is e. So e, remember, is approximately 2.7. Well, for the purpose of graphing, we said we will take 2.7. So 2.7, and what is e square if you want? I think it was 7.4. So what about 1/e? That was 0.04. So you can check that and then do the problem, okay? So I'll let you guys do, and then I'll come back and show. We will check if your graphs are same as my graph. Then again we have something with the transformations. So once we do those, then we can now talk about transformation. So this one is log base 3 of x plus 2 minus 1. So any vertical shift in these graphs is not going to move the axis. Axis will remain the same. But if there is a horizontal shift, right or left, the axis will move because it's a vertical axis. So in this one, you can see here the x plus 2 is suggesting that there is a shift of 2 units to the left. Also, you can see from the domain will be x minus 2 is greater than 0. So which means x is greater than -2. So it means we have to, minimum we can go is up to -2. So axis will move to -2. Yeah. So this is, so we write our transformations here. So base function is the y is equal to log of x base 3, and there is a shift left 2 units, and then there is a shift down 1 unit. So these are the only 2 transformations in this function. And I first plotted with the dashed line, the green line, dashed line, the original function. I took 4 points. Again, these 3 points should be enough. So this is actually, these 3 should be enough. So this is 1/2, -1, and then 1, 0, and then 2, 1. Okay. So the 1, 0 is this one, 1, 0, and the 2, 1. So now what will happen? These will shift. So, but I took one more point, which is 4, 2. So the 4, 2 will shift 2 to the left. So it arrives here and then 1 down. So it comes here. The 4 to the 2 goes to 2, 1. And the 2, 1 goes to 0, 0 because you have moved 2 left, 1 down. And then the 1, 0.2 left, 1 down. So it arrives here. And then this one, 2 left, 1 down. So it arrives here. And then that is your graph. Okay. So now we have 2 more. One is g of x is equal to 2 minus ln of 3x minus 3, and the other one is the, I think it's the, it's the x plus 2 plus log x, 2 plus absolute value of log x. So you already know the function, the graph of absolute of log of x, but that was to the base 2. This is to the base 10. So you should be able to graph this. And only one transformation, just shift up 2 units if you are taking your base function as absolute value of log x. Okay, so try these and then I will come back. I'm going to stop the video here. Next video I will see.